Hey guys, this is Archana from Edureka and I welcome you all to yet another session on software testing. Today's topic of discussion is smoke testing. But before we proceed any further, let's go ahead and take a look at today's agenda. We will begin this session with a brief introduction to what a software build is. Then we will get started with our today's topic, which is smoke testing. We will learn what smoke testing is. We will talk about its features. We will get to know when to perform smoke testing, why to perform smoke testing, and how is smoke testing actually performed. Then we will also learn the differences between smoke testing and sanity testing. Moving on, we will talk about the best practices that you should follow when you perform smoke testing and popular smoke testing tools. Finally, we will conclude this session by doing a demo on how to create best smoke test cases. So I hope agenda was clear to you guys. Let's get started then. Today's world of technology is completely dominated by machines, and their behavior is controlled by the software powering it. So, in this accelerating and increasingly digital business world, software development and delivery is the key to build a competitive edge. The prime objective of any software project is to get a high quality output while reducing the cost and the time required for completing the project. To achieve that, companies subject their software product to different types of testing before it's released into market. And one such testing is smoke testing. Smoke testing is a superficial level of testing conducted on initial software builds by developers to make sure that all the basic functionalities, or you can say core functionalities, are working properly. So before jumping straight into smoke testing, let's just first understand what a software build actually is. When you are developing a simple software program that consists of a few lines of source code, it's easy to compile and execute the code. But this is not the real situation in companies. A typical software program or application usually has hundreds or even thousands of source code lines. Creating an executable program for huge code is quite complicated and time consuming process, as you guys know. So in such cases, you need a build to generate the executable program. The term build is the process by which source code is converted to a standalone form that can be run anywhere on any system. Well, it's not just the matter of compiling the individual components of an application, but the linking them together as well. So you will need to tell the individual components which you have compiled where to find the things they require or depend on to run properly. And this complete process is what we call software build and software engineering. So in simple terms, you can consider build as a particular model of an application or a software that's still in testing phase. This build is further put on the test environment and it's handed over to QA team for testing purpose. Each time a developer fixes anything in the code or if he writes a new code for different functionality, it goes through same process again. So there are a number of development builds planned in any given project. But it is always a risk that build does not work properly on the environment because of number of issues like configuration issues, code issues, regression issues, and environmental issues. So our initial build, after it's developed by the development team, is subjected to basic testing before it's sent to other levels of testing. This basic testing is what we call smoke testing. So smoke testing is a high-level test performed on initial software build to make sure that the critical functionalities of the software or the application that you're testing on is working properly. It is executed before any detailed functional or regression tests are executed on that particular software build. So the process of smoke testing targets all key features and it's often considered a cost-effective approach because you're just checking the basic functionalities and you do not have to spend much effort, time, and cost on that. So if key features aren't working or major bugs haven't been fixed, there's no reason to waste time on further rounds of testing, right? So smoke tests should be scripted. This ensures that you're touching all the major components of the software and no key features or the core functionalities are missed by you. And most of the time, all the high quality smoke tests share common characteristics and area of coverage. Like it involves clicking or navigating through many or sometimes all screens of an application, testing the key functionalities such as sign up forms, adding to the shopping carts, exporting files, moving data, and rest of other things, verifying correct layout of the graphical user interface and visual correctness. So all these are the basic features which we check during any smoke test. But it's optional that even after checking these features, you can add on other features to check on according to your requirements. But the question here is, how important are these smoke tests? Let's consider a simple example to understand smoke test. Suppose if you're given a Gmail application to test, what are the important functions there? Log into Gmail, compose mail, and send. Correct? Yeah. So for instance, if there's an error in sending an email, does it make sense for you to test sent mail, drafts, folders, and other features? No, right? Which means you are rejecting the build without further testing or without testing other functionalities. That's because your basic functionality or the core functionality of your application is not working properly. That's what smoke testing is all about. Of course, thoroughly testing your application is really important for ensuring the code quality. But performing a suite of smoke tests is even more important since it's sensible to get answer to preliminary questions like, can the application that you're testing will be successful without any error? Does the login process function correctly? What happens when you click on the primary buttons or the menus? So, a major benefit of running a smoke test is that it provides quick feedback within a matter of few minutes. And as a tester, you do not have to wait for hours to get the results. As you can see, I have like about 3 builds on the screen, and I want to check the functionality of my last build. So, I have subjected it to smoke test. If all the functionalities are working well, as in if it passes the smoke test, it'll be passed on to next rounds of testing. If it doesn't, the build is either rejected or it's subjected for further development to remove the errors or the bugs that we have found. So that's what smoke testing is all about. Guys, have you ever wondered why the name smoke testing? Since smoke testing came into existence, there are a lot of theories and studies associated with the nomenclature. However, out of all this, only two of them seem appropriate. One theory is that, according to Wikipedia, the term smoke testing likely originated in the plumbing industry. Plumbers would use smoke to test for leaks and cracks in the pipe systems. Sometime later, the term was applied to testing of electronic things as well. Another theory states that the term smoke testing is originated from hardware testing, where a device, when first switched on, is tested for the smoke or the fire from its components. Like power up a device, and if you see a smoke, then well, that's bad, right? So these are like the two most popular theories about a smoke testing. But today, the concept of smoke testing is widely used in software development. While actual smoke may not be involved, the same principles are applied in smoke testing software as well. But to get a better insight into this process, it's important for us to understand various features of smoke testing. So let's go ahead and check them out. First of all, smoke testing is often referred to as build verification testing. So next time you hear someone telling build verification testing, it's nothing but smoke testing. It's known as build verification testing or build acceptance testing, where the build is verified by testing the important features of the application and declaring it as good for further detailed testing. It delivers quick and decisive answers on the viability of the particular build that you're testing on. Smoke testing is an integral part of the software development lifecycle, which ensures that the critical functionality of an application are working well and fine. This you already know because that's the main definition or the concept or the objective of smoke testing. As smoke testing decides the path of the build for further testing process, it's often referred to as intake test. So with the help of automation tests, developers can check build immediately whenever there's a new build ready for deployment. Smoke testing can be done manually or it can be automated. Usually it's the testing team begins manually and then later on they automate the entire process. It also works as a gatekeeper to accept or reject the build based on its stability to undergo through further rigorous and in-depth testing activities. So you can say it's called build verification test or build acceptance testing. It ensures critical functionalities are working fine. It can be referred to as intake test because it decides on the next level of testing. It's often refers to as gatekeeper as well. Smoke testing, as you guys know, is subset of regression testing, but it's not a substitute for regression testing. And it's applicable to different levels of software testing like integration testing, system testing, and acceptance testing as well. Finally, it's a non-exhaustive testing with very limited number of test cases. You don't do testing here very deeply. You just check the basic functionalities. And usually smoke testing is performed with positive scenarios and with valid data. And the entire process is usually documented for referring later on. So these are the basic features. Well, in conclusion, you can think of smoke testing as a normal health check on the build of an application. So, guys, now that we're aware of what smoke testing is and its key features, let's go ahead and answer some important questions about smoke testing. Well, the first question is, when is the right time to perform smoke testing? Or when do we do smoke testing? First of all, smoke testing is done whenever the new functionalities of the software are developed and integrated with existing build that's developed in QA team. It ensures that all critical functionalities are working correctly or not. It is done in a development environment on the code to ensure the correctness of the application or the build before releasing it to QA team. After the build is relayed to QA environment, smoke testing is performed by QA engineers or QA lead. So whenever there's a new build, QA team determines the major functionality in the application to perform smoke testing. These actually answers our second question as well, which is who performs smoke testing. Like I said, it's done by development team before build is released to QA team. It's done by QA team before subjecting the build to further rigorous testing. So smoke testing basically is performed either by developers or testers or both sometimes. Moving on to our next question, why to do smoke testing? What are the benefits or advantages of performing smoke testing? Smoke testing offers various advantages to team of testers and allows them to effectively evaluate various aspects of the software. So let's check out what those benefits are. First of all, it helps you in finding the bugs and defects in the early stages of testing itself. You can uncover and fix as many as 80% of the bugs that discover simply by configuring or executing a simple smoke test. So with smoke tests, you might be covering only 20% or less than that of your test cases, and yet you can catch up to 80% or more of the bugs. Secondly, it minimizes the integration risk and help in finding the issues that get introduced whenever you integrate the components after unit testing. Smoke testing can be carried out in small time. It can be executed within few minutes for every particular build. Smoke testing also improves the effectiveness of the QA team. Instead of spending and wasting test cycles by attempting to run a large test suite when there are issues, QA team can simply opt for smoke testing. Smoke testing also reduces the manual intervention because you can easily automate the entire process and the test cases are not many here. It helps in verifying the issues fixed in the previous build are not affecting the major functionality of the application currently. This way, it improves the quality of the system that you're testing on as well. And lastly, very limited number of test cases are needed to perform smoke testing. And it also offers the advantage of getting faster feedbacks as it's frequently run very quickly. So these are the advantages. Let's list out. First of all, you can find defects and bug in the early stage of testing. Integration risks are reduced when the components are combined. There's no need for manual intervention. You can opt for automation. It improves the effectiveness of your QA team. It saves a lot of time and effort on testers' part. It improves the quality of the system as a whole. And the most important thing is very limited number of test cases are needed to perform smoke testing of entire application. So smoke test, take your code, build it, run it, and verify a thing or two. They will not verify that your software is 100% functional or not. In a production app, they will act as a quick bailout. If the smoke test fails, then the whole build is failed. And the entire process is so quick that you do not have to waste a lot of amount of time here. So my point is that for a simple application, smoke test is often all you need. Next question is, how do you actually perform smoke testing? Well, it's quite simple and it's very similar to other testing process. So the common first step for companies who want to build a suite of smoke tests is that they start with manual testing. Builds are deployed by the development team and are then sent to QA team or testing team for further rounds of testing, or you can say smoke testing. Now, once the QA team receives the build, according to the requirement, they'll start designing the test cases to expose all the errors before this build is released to market. So once you have the test case, you read and create a test suite. A smoke test suite combines a number of smoke tests into small suites of tests so that when application is ready to deliver to pre-production environments, developers will know in matter of minutes whether the latest build is worth sending it to next level of testing or not. So to be efficient and purpose built, a smoke test suite should contain easily manageable number of test cases. Well, the recommended number of test cases is generally 20 on the low side and around 50 on the high side. Any less than this and you're probably not covering enough amount of test cases, And any more than this, you're probably trying to cover too much ground at a single point of time. So you should always concentrate on sizing your smoke test suite. That's very important step. Once you have suite of smoke tests defined, you're going to want to think about automation, right? Automation can improve the quality and it can be efficient and it reduces a lot of effort and time on testers' part. There are many reasons for automating your smoke testing, like I said just now, but the best reason is that your test will run faster, more consistently, and the written results automatically. There are a number of automation frameworks available in market that you can prefer to perform smoke testing. So once you have your suite created and an automation framework selected, you will want to think about a couple of key areas in order to keep your test running and healthy. And what are those? You need to keep track of test creation and maintenance. You need to execute smoke testing on daily basis. You need to access a penalty on any developer whose contribution fails to pass. You should consider continuous integration made possible with such as Jenkins and Circle CI. Lastly, execute the test cases and clean up the entire setup. Cleanup might include stopping a server, deleting files, or emptying the database tables. This can also be done before the initial setup because so when you start testing, the entire environment is clean and it's like a clean slate where you can begin testing. So these are general steps that you can follow to perform smoke testing. Well, these are the general steps that you need to follow, but let's consider a simple example to understand how is smoke testing performed in real world. So assume that you're working on an e-commerce site. When a new build is released for testing, as a software QA tester, you have to make sure whether the core functionalities are working or not. So you try to access the e-commerce site and add an item into your cart to place an order. That's a major flow in most of the e-commerce sites. You agree with me, right? What's the major flow? You log in, you add the item to your cart, you purchase it and sign out. If this flow works, you can say that the build is past testing. You can move on to next level of testing like functional testing and regression testing. So here's an example. You have a build which is being released by the development team. It's been sent to you or the QA team. So you create a set of test cases and combine them and place them in a test suite. You execute the smoke test. What are the smoke tests that you're going to execute on? First, if you're able to access the home page or not. After that, you access the menu links. Are you able to access the menu links or not? You check that part. After that, you add the item to the cart and check if the functionality is working. The main functionality is after adding the items to the cart, you need to purchase them. So that's what we're checking basically in smoke testing. So you're checking the checkout and the place order functionality. If this functionality is past the test, you move on to the next level of testing. Otherwise, the build is rejected and it's sent back to development team to make changes. So it's as simple as that. Moving on, there's another term that you should know about, like sanity testing. It's often misunderstood with smoke testing. The sanity testing is done on a software build after it has gone through smoke testing and other levels of testing. Sanity testing is done to ensure that the bugs are fixed and there are no persisting problems with the application. So that's the major difference. Motive of smoke testing is to measure the stability of newly created builds so that you can move on to next round of rigorous testing. Whereas sanity testing is done to check either new functionality or the bugs that have been fixed properly without going any deeper. So the objective of sanity testing is to verify the rationality and the originality of core functionalities. It might sound complicated. The simple thing is that whenever you start on initial builds, you go with smoke testing. After your initial builds are smoke tested and after they've gone through other levels of testing, you perform sanity testing. That's the most basic difference. So in smoke test, you verify the critical functionality or the core functionality. In sanity test, you verify new functionality and check out if there are any errors. So guys, with this, we have almost covered all important concepts which are related to smoke testing. Now let's check out the best practices that you should follow when you're performing smoke testing. First of all, conduct smoke tests during the early stage of project. Record all your smoke tests. It's a very good practice and it'll provide you reliable data later on. Smoke test cases should be short and very precise, like less than 6 minutes at most. The intention with smoke testing is to catch those bugs that block the development progress during the initial stage of a project. Your goal should be to get the developer to resume the development as quickly as possible without having to wait for the complex and drawn out test phases. So at max, you can go up to 60 minutes. Well, it's not a fixed time limit, but that's what is suggested to be effective. Automate whenever possible. Tests will run faster, more consistently, and they'll return results automatically. Maintain a test case repository. Chances are 90% of your team are working on projects that bring new features or transform an established project, or they're making changes constantly. So it's always suggested to maintain a test case repository to keep track of all the test cases. Don't just stop with smoke testing, it's just a first level of testing. Move forward with other rigorous testing if the build has passed the smoke test. And once again, remember that you just have to use smoke test to test the basic functionalities, so don't go testing very deep. Now, talking about tools, many tools are available in the market to perform smoke testing in an automated way, actually. Top tools include Selenium and Phantom.js. But the question here is, which tool is best out of these two? Well, both of them have their pros and cons. Let's take a look. Coming to Selenium, I'm sure you might have heard of it. It's an open source automation tool and a JavaScript run automated testing frameworks that enables you to run tests across different platforms. So the most commonly used browsers with Selenium are Chrome, Firefox, Safari, and Internet Explorer. Selenium, it does have a downside when compared to Phantom.js. It needs a user-friendly graphical desktop for running the test, making the entire process of testing literally slow. However, you can leverage the full potential of Selenium when you set up virtual machines for various operating systems and connect them all together. What developers love about Selenium is that its capability to use bindings that allow them to run tests on common programming languages like Java, which is a native language of Selenium, JavaScript, Python, Ruby, and C Sharp. So basically, all these languages are supported, and you can use any of them to perform tests on Selenium. Coming to Phantom.js, it's an incredibly powerful tool for testing as it supports several web standards, and this makes it suitable option for automation and integration with CI tools. Phantom.js gives you the advantage of capturing screenshots. Being a headless version of WebKit, it works as a windowless command line browser. So it's without graphical user interface portion, and it's mainly because of this fact that the entire process of testing is very much easier and faster on Phantom.js. Phantom.js works as a single version of WebKit, so that's the main disadvantage of Phantom.js. So I hope this has cleared the differences between both these tools. And again, when it comes to choosing out of them, it's up to your requirements. So go ahead and think properly and choose one that suits your requirements. That brings us to the end of the theory part. Now let's check out how to write smoke test in the demo part. We won't be performing any kind of smoke test here. We'll be learning how to write smoke test cases so that you can send your application or part of your software to next level of testing. Well, I'm using Excel sheet to write down test cases here. So guys, here we are. In this demo, we'll learn how to write simple smoke test cases. And for that purpose, I'll be using Excel. You can use any other tools to write test cases. So let's give a proper name to this sheet. Let's say smoke test cases. Before we begin, the most important thing to remember is that speed is better than thoroughness when it comes to smoke testing. So don't worry about trying to get everything 100% right the first time. You can always improve later on. Just think about the things you would normally do in your application and make a list where each line is a separate test. For example, let's say if you're browsing through an e-commerce site, you found an item that you like and you have added the item to the cart. And after that, you've logged out. Now let's try to write a smoke test for this particular scenario. Before we actually get started with the test cases, let's go ahead, like I said earlier, and create a test plan where each line should indicate a separate test. So let me give a project name, and the name would be smoke test application for e-commerce site. Okay. So if you want to test on e-commerce site, what are the basic functionalities that you want to check according to the scenario which I said earlier? The first thing would be the login functionality, right? And the next thing would be the cart functionality, as in, are you able to add the item to the cart or not? I'm just skipping the purchase option here because the test cases get very complicated, and I'm sure you guys know how to write test cases. If you do not, there's another video in the Edureka software testing playlist. You can go ahead and refer to that. The video is how to write test cases in software testing. It's explained with an example in a very proper way. So if you want to know how to write test cases, you can refer to that. Coming back to today's demo, what are the functionalities we were discussing? The login functionality, cart functionality, and obviously the last thing is sign out. So these are the three things that we want to check. And now we're going to write the test cases for these three functionalities. So every test case has few components, and you can add on more components according to your requirements. But as for today's, let me add few components here. Let's say about 6 of them, the very basic. So the first thing is test ID, then the test scenario, then the description part, the test steps, expected results, actual results, and the status. So let me explain you each of these properties. Give me a second. Okay. So the test ID, because you have lot of test cases, you need to assign an ID to keep track of them. The scenario is very simple, explain in very detailed way what you're going to test on. Description is a one-line description. It should be very brief and up to point. One look at it, any tester or anyone who's looking at it should understand what you're testing on. Then these are the test steps, as in what you're testing on, the steps that you follow. These are the expected results, the results that you're expecting. Actual result is nothing but the actual result which you're getting after performing tests. And status is if or not expected and actual results meet or not. Based on that, the status will be either pass or fail. So let's start with the first test case. What we want to check here, the first case is login. And description would be test the login functionality of the application. As simple as that. It should be very short and up to point. In this case, application is nothing but the e-commerce site which we're testing on. And what would be the test steps? The first step would be to launch the application or e-commerce site. And the second step would be to navigate to the login page. Before we proceed, guys, I need to remind you, these are just sample test cases. For a particular scenario, you can write any number of test cases according to your imagination and what you can think is relevant. For example, when we go for login functionality, I can go ahead and write a test case for registration as well. Because to become a user, first you need to register, right? But I'm skipping that part here, just so we won't take a lot of time for you to understand the concept. But you can go ahead and add the test case as well. So what would you do the next thing after you navigate to the login page? Obviously enter the username, then enter the password. And the last step would be to click on login button. So what would be the results that you're expecting? Login successful. And let's say the actual results that you've got after performing the test case is as expected. So the status definitely be pass because the expected results and the actual results are nothing but same. Moving on to second functionality, which is cart functionality. We want to see if we can add the item to the cart successfully. That's what we're going to check. So what are the steps involved? The first step that you would do is select the item, right? The next step would be to add the item to the cart. Or you can say click on add to cart option or button. And what would be the expected result? Item added successfully to the cart. And suppose item is not getting added. So you've tested the functionality, but the item is not getting added to the cart. So what would be the status? Definitely fail. This particular component has failed. So the third component would be to check the sign out. Check out the sign out functionality. It's very simple, right? First thing is you navigate to settings. Well, again, it depends on the application. Sometimes you have the logout option directly on the screen, but sometimes you need to go to settings and check for the sign out option. And what is the result that you're expecting that should happen when you actually do that? The user should be able to log out. And let's say user is able to log out. And based on that, what would be the status? It's pass. So that's it, guys. We have written test cases for a simple scenario of an e-commerce site. As you can actually see, these are very simple set of test cases that you can easily pass to a manual team, and you do not have to give them a lengthy explanation on what to test as well, because it's very clear that all they have to test is login functionality and if the item is being added to cart properly or not, and after adding the item, if the user is able to log out properly or not. So your test cases should be in such a way that they shouldn't be complicated, and whenever a QA team takes a look at that, they should understand what they're actually going to check. But again, these are the basic functionalities. You can include any number of test cases for the functionalities. But the main purpose of smoke testing is to check the core functionalities. So when you pass these test cases to manual team, they should be able to easily understand. Even if you are going to automate or take the trouble of writing Selenium code, you should handle these steps very easily. Now, after you've got a solid, fast, automated smoke test suite in a place, a good evolution would be to integrate your full suite of tests into a CI tool or a continuous integration tool. This continuous integration tool or CI tool can automatically initiate your test suite. It will communicate you with the alerts and it finalizes the reports concerning the results of all the tests. Now, if all these three critical components after being tested or smoke tested by the QA team work fine, it means that the build is stable enough to proceed with detailed testing. So that's all about smoke testing, guys. Very simple, right? That's it, guys. With this, we have come to the end of the session. In conclusion, smoke tests offer you a simple, straightforward, yet supremely effective option to speed up the bug fixing efforts. Developers and others alike can use smoke test in software projects and can dramatically improve the code quality. So if you guys have any doubt regarding the demo that we did and any of the theory part, please do post them in the comment section below and we will get back to you as soon as possible. I'll meet you in next session with another interesting topic, guys. Thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!